Swayam Prabha. Digital India. Educated India.
Hello everyone. So today we will continue with energy efficient pumping and cooling systems. So we will see energy efficient pumping system, under which we will see energy efficient fans, low energy Hvac system, low energy Hvac system with smart control and automation. So what are energy efficient fans? Energy efficient fans are fans that are designed to provide maximum airflow. Now these consume minimum electricity, and this makes them very vital for reducing energy use in residential, commercial, industrial settings. These fans are very commonly seen in HVAC systems. We see a lot of these in industrial settings also. And even this has now come into our daily household appliances. So, what is this efficient motor design? So, this is brushless DC motors, BLDC as a system. So, what is BLDC? BLDC fan means there is a BLDC motor used in the ceiling fan, and these can be used in residences. With the use of BLDC motor in ceiling fan, it is seen that we can save even up to 60% of electricity cost with the help of these BLDC fans. So BLDC the lifespan of BLDC fan is more than a normal regular ceiling fan, because one major thing that happens is there is no heat generated in BLDC motor. Hence, it increases the lifespan of the ceiling fan bearings. Also, the chances of failure of the winding is very, very less, because they use high thickness copper wire in the winding. These motors are very efficient compared to the traditional AC motors in case you are using permanent magnet synchronous motors. So they are very efficient than the conventional induction motors, reducing energy loss. And these are they offer variable speed control and consume less energy, especially at lower speeds. Then you have high efficiency induction motors, IE3 and IE4. Okay, so these are induction motors, and these motors mean they meet international energy efficiency standards and reduce energy waste by improving the motor's electric performance. Now, if we see what is brushless motor technology, the traditional motors use brushes and a commutator to transfer electric current to the motor windings. In BLDC motors, this function is replaced by an electronic controller which switches the current through the motor windings without any physical contact. This will eliminate the wear and tear caused by brushes, reducing the maintenance and increasing the lifespan of the motor. BLDC motors There is no brush between the rotor and stator for transferring electric supply, so it is called as brushless DC motor. If you look at the rotor, in BLDC ceiling fan, there is permanent magnet used in the rotor. And if you look at the stator, the copper winding used in stators which produce magnetic flux after supply of electricity. So effectively, what is the use for us as architects and designers in using BLDC fans? These fans are widely used in household appliances, and you can see what happens. Earlier, we had a regular fan which used about 75 watts. Then we have a 5-star rated fan which uses 50 watts. What is a 5-star fan? I will tell you later. And BLDC fan uses 32 watts only. So look at the comparison. A regular fan uses 75 watts, 5-star fan uses 50 watts, and BLDC fan uses 32 watts. And this gives us 60% energy consumption over a regular fan. One big advantage is that these can be operated with a remote control. BLDC fans you can operate with remote control, and the lifespan of the fan is also long. Now, how much can India save in terms of using BLDC fan? So, India can save, it is estimated that 400 million people use fans in India. So, if we calculate the electricity for a normal 75 watt fan, then the amount of electricity required is about 1,09,500 megawatt. And if we calculate for BLDC fan, we will require only 46,720 megawatts. This means we can save 62,780 megawatts, which is approximately 60%. Because of this, India can save 40,000 crores in rupees, and the savings in electricity can translate to saving 42,000 tons of coal to generate that much of electricity. And this translates to a reduction in CO2 emission by 60,000 tons. So this is the environmental and economic repercussions of using a BLDC fan, which is a simple replacement of a regular ceiling fan with a BLDC ceiling fan, with an added advantage of being able to operate it with a remote. Now, what are its features? First is, it has an optimized blade design. So what is optimized blade design? It has aerodynamic blades. So the shape of the fan blades is very important in determining airflow efficiency. So having streamlined curved blades will reduce air resistance, and this will allow the fan to move more air with less power. Second is advanced materials. So we can have lightweight, high strength materials, say like fiberglass or aluminum, which can reduce the drag and strain on the motor, thus improving the overall efficiency. Besides, we can have variable speed control also because of variable frequency drivers called as VFDs. So these are electronic speed controllers which will adjust the motor's speed based on the airflow requirement. This can reduce energy consumption and also lower the demand of electricity. Then we can have intelligent control systems. So these BLDC fans or smart fans will incorporate sensors and control systems to adjust the speed as well as airflow automatically based on environmental conditions, occupancy or system demand. Then their other features is the energy efficient certifications. So fans with energy efficient certification is very important for us because no, for many reasons. One is they can be energy efficient because there is a certificate. They can lower energy consumption compared to non-certified products. Besides, it is more justified to have them if we want to go for green building rating of the buildings. Then they operate with low noise. So energy efficient fans will incorporate designs that will reduce the turbulence and mechanical friction, and this leads to quieter operation. So this is because we use a smoother airflow and less energy. We use, and this is because of smoother airflow and less energy is lost to vibration and noise. Then it has compact and modular design. So fans with smaller, more compact motors and blade designs will consume less energy while still providing enough airflow. So in industrial settings, modular fan units can be scaled up or down based on the area's airflow requirement, which will prevent overuse of energy in areas where the demand is less. Then these can operate with high frequency. So BLDC motors, they are more energy efficient than your regular AC motor. Why is that? Because they can convert more electrical energy into mechanical energy because of their efficiency. This can lead to lower power consumption, especially when you run at variable speeds. Then you have the feature of variable speed. So BLDC fans can easily adjust their speed according to demand. So the electronic controller will modulate the power supplied to the motor, allowing exactly the required amount of fan speed. Then these can be very quiet in its operation. Since there are no brushes which can create friction, the BLDC fan will operate very quietly than a brushed motor fan. This makes them ideal in almost every situation like home or office or hospitals where the patient needs a silent place, and then a computer room where noise reduction is essential, and we as architects go that extra mile to make it noiseless. Now, where all can we use this BLDC motors? So what are all its applications? Its application includes household ceiling fans. Then they can be used in electric vehicles like scooters or cars. They can be used in industries in a number of industrial equipments. They can be used in water pumps. We already saw variable speed water pump along with BLDC motor, and then they can be used in drones and other home appliances including ceiling fans. What are the advantages? The advantages are, first is they are energy efficient. Through a mathematics I showed you, they can be even up to 60 or 70% efficient as they consume that much less energy. Second is they can be precise control So the electronic control system will allow for precise speed adjustment, and that too with quiet operation. They don't make too much of noise. So with fewer moving parts and reduced friction, they operate with minimal noise, making them extremely suitable for noise sensitive environment, and therefore they are environmental friendly. So BLDC fans will contribute to energy savings and reduce the carbon footprint also. Next we will see low energy HVAC system. So what is a low energy HVAC system? It is a HVAC system which is designed to have lesser energy consumption, but at the same time it should maintain optimal indoor air quality, thermal comfort and humidity control in all residential, commercial, industrial buildings. These systems will use energy efficient technologies, smart controls and sustainable designs so that the operational cost will get reduced and the environmental impact will also be more. So we need low energy HVAC systems so that we have better thermal comfort, good indoor air quality, a more energy efficient system with low energy heating and cooling, with intelligent controls and an efficient ventilation system, probably even integrated with renewable energy. How can we get low energy HVAC system? By first is variable speed compressors and fan, something I had spoken a little earlier. So variable speed compressor and fans will adjust their output to meet the precise heating or cooling demand at any given time. So by running at lower speeds when full capacity is actually not needed, these components will save energy compared to a traditional system that operates at full speed or full cycle off and on. So what are the benefits of variable speed compressor? First is there is no need to unload. No need to unload. Means what? The ability to start and stop under full system pressure is not there. Second is reduced power cost. Reduced power cost. So there is no loss of energy through running unloaded. Then reduced power surges. Power surge gets reduced. So you can avoid peak currents from starting air compressor motor. And besides all of this, what is most important to us is these are highly energy efficient. How energy efficient are these? Energy efficient. They are energy efficient up to at least 30%. 1/3 as compared to the typical fixed speed compressor. Then they require precise electrical control. So precise electric control, which means motor speeds can be slowed down, brought to a halt or even revved up. And then we can have minimum system leaks. Minimum system leaks. So lower system pressure will reduce the risk of leaks. Then next we see demand controlled ventilation, which is called as DCV. So what is DCV? DCV systems will use sensors to monitor IAQ. What is IAQ? Indoor air quality metrics. What are indoor air quality metrics? They can be CO2, the amount of carbon dioxide levels in the air, humidity, and other gases like CO2 and things like that based on occupancy. So the system will adjust ventilation rate based on actual needs, and this can cause reduction in energy consumption when ventilation isn't required or when occupancy is very low. So what all are the advantages of having DCV in a building? First is reduced power consumption of the exhaust fan. Reduced power consumption of the fan, okay, of the exhaust fan. So by reducing the average airflow rate, DCV systems will allow the exhaust fan to work very well below the maximum airflow at very low power, and this can result in less clogging of the filter. Less clogging of filter can happen, or less clogging of air ducts and terminals can happen, because inherently there is reduced airflow in these kind of system, and that leads to reduction in the total amount of particulates that can be lodged into the components. And because of this, there is increased life of DCV exhaust fans. So extended life. So it has a increased life because by reducing average airflow year on year, DCV will permit a reduction in the demands placed on the exhaust fan. The load on the exhaust fan is less, and this increases its longevity. This is because longevity of the exhaust fan depends upon the power at which it works, and the power is directly related to the average airflow through the ventilation system. Then we have greater availability of pressure and airflow for the terminals. So you have greater pressure, greater pressure and airflow for terminals. So the rooms or dwellings with low airflow requirement, these will release the air duct space for the rooms or dwellings with a higher need for ventilation. So these can then benefit from the DCV from all the pressure and flow potential of the ductwork. Then we can have reduced size of air ductwork. And what happens when you have reduced size of ductwork? Reduced size of ductwork means for an architect it's a boon, because you can gain that much of height, that much of duct height you can gain for an architect when it comes to having your false ceiling design or anything like that. So and then your total space required for ducting can also get reduced. Third is the thermal energy storage system. So thermal energy storage systems will store energy in the form of heat or cold during off-peak hours when energy costs are lower, and use it during the peak hours to reduce energy consumption. This is very effective in large commercial buildings which have very high cooling or heating loads. So what happens because of this? You can achieve energy security, which is an important goal in industrial sector. So you can have energy security. Then you can store surplus energy and reduce the cost. So you can store surplus energy, which you can use at off peak hours. So when you don't want, you don't spend, and when you need, you can take this part and spend it. And then we have reduced emissions by increasing the energy efficiency. So what are the technologies for low energy HVAC system? We can have solar powered HVAC systems. So solar powered or solar assisted HVAC system will integrate solar thermal or solar PV photovoltaic panels to offset energy consumption. Solar thermal system, this can directly power the absorption chillers for cooling, whereas photovoltaic systems can supply electricity to power the fan, compressor and other HVAC components. Next is having geothermal assisted HVAC systems. Some advanced low energy HVAC system can integrate geothermal technology for heat rejection or extraction, and this can have a reduced impact on the workload of the air source heat pump, especially if you are looking at extreme weather conditions. And then you must go for building envelope and insulation optimization, because a good building, a very well designed building envelope will include proper design in the form of insulation, because we are talking of reduction in air infiltration in the context of HVAC system. So you should have energy efficient windows, you should have low E coatings which can reduce the heating and cooling loads of a building. And then the next aspect is we must have a good building automation system, BAS. So what is BAS? Building automation systems. These are platforms which will integrate the HVAC system with other building technologies and energy use such as lighting, security, and it will have a centralized control and monitoring. Because of this, we can optimize HVAC operation by adjusting heating, cooling and ventilation in response to occupancy, weather and energy demand. Building automation systems can include predictive controls that use weather forecast and other historical data of the weather and climate of the place to anticipate the demand on heating or cooling load of the air conditioner, and it will adjust the system in advance for maximum efficiency. Next is using IoT and smart sensors to have low energy HVAC system and have smart control and automation. So IoT or Internet of Things sensors will be embedded throughout a building, and this can continuously monitor the parameter, thermal comfort parameters such as temperature, humidity. It can monitor the occupancy level and also IAQ or indoor air quality. These sensors will enable real-time adjustments to HVAC settings, ensuring that only that much of energy should be used whenever it is needed and wherever it is needed. Then we can have Advanced Energy Management System or EMS. So EMS platforms will collect data from HVAC systems, lighting systems and other energy consuming equipments, which will allow the building managers to analyze the usage pattern and optimize energy consumption. So in total, if you see, what are the benefits of low energy HVAC system, especially if you are going to plug in with an automation system? First is reduced energy cost. Then we can have lower carbon footprint. We can have improved comfort, enhanced air quality, and long-term savings. So today we saw, in this class we saw low energy HVAC systems individually as well as low energy HVAC system plugged in with automation systems. With this, we will stop today's class and continue with another topic in the next class.